Hey guys, welcome to Programmer Guide. Now we'll be discussing about the Docker overview and the benefit of Docker. Docker is the most interesting technologies and one of the must-have technologies for cloud native applications. So we'll discuss about different benefit of Docker and how we can leverage this Docker technology to build your application which should be a cloud native. So let's start. Now assume you are a project lead and you are asked to create a deployment stack which is using one web server, one database, one messaging application, and one application logic. Maybe application logic is written in Java, Python, or Node.js, or some other application logic is there. So for that, what are the things is required? You need the specific hardware, some OS, some library, or dependency. Now coming to the OS, library, dependency, and hardware, each and every different component for web servers is required a separate requirement of hardware or OS compatibility. Similar case for MySQL database, maybe it's required for your messaging application, let's say it's a Redis. So same thing is happening for your application logic also. So everything has a different versioning. This requires specific OS, specific library, and dependency as well. Now even in the web servers, database, messaging application, when you are talking about this application is communicating to each other, even these applications is also having a certain set of constraint which should be made until and unless this application will not be working. So it should be something like that. This web server is connected with this hardware and also OS, some libraries, some dependency. The same is applicable for MySQL and Redis. Now, just think about it. Only for your 4 component, it's making so much complex. Now, tomorrow, your application is growing and you add some more component like some new web server, some new databases, or let's say tomorrow your MySQL is not performing well and then you upgrade it with a new server like an Oracle, or you added some more messaging applications, or you need to, in every year, maybe you have to update your version of your software as well. So, in that cases, every time you have to do the same practice to verify each and every level of library, dependency, OS, hardware dependency. Now this is just for a single place where you are managing all these things. Now this application is moving to your test environment. Once again it's moved to your production environment. Now whoever is maintaining your application in your production environment, he has to maintain each and everything, each and every library. If anything is missing, once again this application is not working, then it's a hell lot of things, right? Even tomorrow, let's say another developer onboarded, even that for that guy to prepare a single development environment, he has to go through the certain criteria. Let's say he's using your Windows application where he is writing your own Java logic, but your application actually using in the production environment one of the Linux way. That time whatever library he is using, maybe it's not the same one which actual production server is using. So it's a real mess environment. This is called matrix from hell. There is a fun fact about it. If you are already working in different development environment, or you are building your application in your setup where there is a separate test team, separate production team, and a separate development team. Many times some production guy reported an issue and saying something is not working, and when you test it in your environment, you said everything is working, it's not an issue. Then it's a replication of same issue in your environment is very much challenging, and that time there is one fun statement is there. You say, okay, it's working in my laptop. Customer say, okay, then ship your laptop. Why we are running things in your production environment? So right? So that's another fun fact about it. So what's the summary of it? We are facing compatibility, dependency issues, huge setup time, different test, pod, and dev environment make things more and more complex. Now what is the solution? Solution is run each and every component, your web service, your messaging service, or your database, or your application logic in a separate encapsulated environment. For that, we need to containerize the applications. And who can help you to containerize the applications? That's the Docker. Docker is software. And after that, we run some encapsulated container on top of Docker software. What it will do? It will just find all your libraries and dependency corresponding to your component and created a separate individual environment which will be having his own mount point, own network, own application space. So that's how Docker can help us. Now the difference between container and virtual machine. To create a virtual machine, we definitely need an hypervisor. So it could be anything like OpenStack or VMware or maybe a KVM. In Windows system, there is another thing is called Hyper-V is also there. So using those hypervisor, we can create a virtual machines. And for the Docker, container, we don't need to create these virtual machines always. We can directly install OS on your physical server, and on top of it you can install your Docker, and using your Docker software you can directly launch your container and bind your applications and libraries inside a container. So due to that, if you compare between these two, virtual machine is always take more utilizations and also size. So utilization, if I compare between these two, for a virtual machine, you definitely need a guest OS to be running inside a virtual machines. After that only we can install your libraries, dependencies, and on top of it your application can be running. Corresponding to that, for a Docker container, we don't need a guest OS inside your container. Container internally uses the actual host OS kernel. So we'll discuss about these things later tutorials, but for now you can just think about it. Your container is not having any host OS. Because of that, resource utilization point of view, RAM, CPU and all these things requires a very less amount of resource compared to the virtual machines. Even in the size, if you install a normal OS, it takes a size of more than a GB, and for a container perspective it requires a MB, not a GB even. So that's why when you are not booting the complete OS, boot up time is also very fast for container compared to the virtual machines. We'll discuss about these things in later tutorials as well. One more mistake people generally ask: containers are not a lightweight VM. Virtualization is a different concept and containerization is a different thing. Don't mix and match these virtualizations and containerizations. Both of them has different level of use cases and benefits. Let's understand containerizations and virtualizations with an example. Let's say you have built two big houses which have 10 bedroom, 4 washroom, 2 kitchen, something like that. Now in these two houses, 2 families are staying, but those 2 families assume have a very less number of people. Maybe first family is having 3 people, second family is having only 4 people as a family member. This house can accommodate more people because it has the ability and resources as well. But with these situations, we cannot able to accommodate more people. Now with the same place, we have built a small apartment, and each and every floor of this apartment we have assigned to a single family. So previously only 2 families can able to stay in these 2 houses. Now in this 2 apartment, you can see total 6 families can stay because each and every apartment has 3 floors. Now in the same place, we have built a multi-storied apartment where instead of assigning a single floor to a single family, we say in a single floor we will build some 2 BHK room, some 3 BHK room, or some 1 BHK room. According to the preference of the families, we will allocate the specific room to those families. Now think about the same concept in terms of containerization and virtualizations. The first one, that is how our classical application used to run directly on your physical server. We used to have 2 different physical server and we used to host 1 or 2 application on that. Although it is not consuming the entire resources, we are still unable to host another application in this environment and unable to optimize this resource as well. So virtualizations in the next level help us to create certain level of VM or virtual machines on top of this physical server, which help us to optimize a resource in a certain level. Now instead of running single application or 2 applications in 2 physical server, now we can run more than 2 applications in a same server, optimizing the resources. Now coming to the containerization. Now let's say we have already virtualized the environment. So we have initially 2 physical server, and a second step we said okay, we have created a virtual machine. So virtualization also done. Now in the same floor, instead of assigning one application to 1 VM or 2 VM, we hosted multiple VM, and inside that we created certain container or multiple container, so which can host multiple applications. In that case, if you think about the abstraction layer, for a user perspective, virtual machines also, it's just a normal server to the user. So he can still use 2 virtual machines to host a single application, although those application is not at all using the full resources of your virtual machines. In that case, we don't have the ability to optimize the resource in your virtual machine. On that point, containerizations help you to create multiple container inside your virtual machines, which can help you to host multiple applications inside a VM as well. Now let's go to the one step further with the previous understanding. Let's say we have one building. The builder of this property assign different flow to different families. That's the part is done by the hypervisor. So hypervisor created a VM on top of your physical server. Next step is each and every family decided, okay, instead of using the complete floor, we'll share entire floor resources with a multiple family. So they segregated one floor with a multiple 2-bedded room, 3-bedded room or 4-bedded room. That is the part is doing by Docker. Docker can be run directly on your physical systems and host your application. Other way also, even you can introduce a hypervisor to abstract your physical layer, create a virtual machine on top of physical layer. After that, install a Docker on your virtual machines and host a container. In that way, we can also better use of resources, and also we can hide your physical layer from the user perspective. I hope we have understood the difference between the Docker, container and virtual machines and the benefit of using together. Now we'll be discussing about another important topic, sharing the OS kernel of Linux OS. So you might have heard different kind of Linux OS like Red Hat, Ubuntu, Fedora, SUSE. But the bottom line is at the end of the day, each of the OS is using same Linux kernel. So what makes the difference between two different operating systems? That's the software packages which comes within this OS. That is the part is making the difference between the one OS to another one. Docker is leveraging the same concept of sharing the kernel. So once Docker is installed in one of the Linux operating system, and on top of it, when you created a container of any type, let's say you have created a container for Red Hat or you have created a container for Ubuntu. Although if you go inside those container, you might have seen that a container is running Ubuntu releases, but the end of the day, base level kernel packages are not part of this container. Docker is intelligently using the host OS kernel. Due to that, whenever we are starting any Docker container or stopping any Docker container or rebooting any Docker container, it's a very fast process because actual garbage packages, boot level packages are not there inside a container. So that's why this container very fastly booting up. In Docker world, you might have heard two things very frequently. One is called Docker image, another is called Docker container. Docker image is nothing but the actual executable packages. It's just like a template of your runtime environment. Docker container, in the other hand, is a runtime environment of your Docker images. So you can create a multiple runtime environment or Docker container from a single image. Docker images, when you build it, it needs to be pushed to some of the private or public repository. Docker public repository is called Docker Hub. So you can go to the hub.docker.com and you can find out multiple existing official images already available in Docker Hub. You can use those images or you can build your own images. So that's it for this tutorial. Hope I have given you a certain level of understanding of Docker. I know it's a very big and vast topic. We'll be discussing about the different Docker topic in depth in the subsequent tutorials. One last one for a fun fact. Do you know what is the Docker mascot? You might have seen so many pictures about the Docker which is saying a wheel, maybe carrying some containers. But in actually, this is just a Docker logo. It's not a Docker mascot. The fun fact is Docker mascot is a tortoise. Its name is Gordon. It even have his own Twitter account. You can go and check his Twitter account. The name is Gordon the Turtle. So that's it for now, guys. Hope to see you in the next tutorial. Thank you all.